again, and welcome to KubeCon Cloud Native Con again. I'm Pang, and my full name is just like my fellows has already pronounced very correctly, Sunyanan Choochotkaew. Thank you so much. Yeah, I'm a staff research scientist at IBM Research, and at the same time, I'm a CNCJ member. As you may know, CNCF local community that Nagamura has been already introduced in the previous keynote sessions. And today is actually my great honor to be on this stage as an ordinary researcher. So I just would like to take this opportunity to talking about my experience on doing the research, at the same time contributed to the open source, how it's linked together and how it can reinforce each other. Forget to take this one, okay. So I would like to start research on open source. They are both rely on three similar principles, that is sharings, collaborations, and transparencies. Both are aiming to drive the innovations by lowering the barriers and reducing the restrictions, constraints. So on top of that, they can reinforce each other. Research can leverage open source tools to test, build, scale our idea in a very efficient way. At the same time, open source it can benefit from the research as well in terms of to stay tuned to the cutting edge technology. To make this more concrete, I would like to focus on my own research field, that is intersections between cloud and HPC AI. Back in 2022, I was in the conference focused on cloud computing. That was our discussions on how we can converge between the cloud world and HPC CNI. At that time, it's very skeptical. There's many discussions go around. But fast forward to today, we can see now AI is already dominating conversation and topic in the cloud domains, even like this KubeCon Cloud Native Con. In the research community as well, the intersections of clouds and HPC AI has become very exciting and highly active areas of explorations. And today, I would like to share how open source is playing a key role in accelerating the research and innovation in AI. First, let me introduce what I call it our open source full research production cycles. I just made it myself. So the full of this cycle is the open source projects. The open source projects is the full to the engines of these cycles, that is their underlying infrastructures and platforms. Within the infrastructures and platform, we do develop, testing, validate our idea and hypothesis in research. And this activity leads us to the tangible product like academic papers, patents, articles, which can then sell back to their cycles, to their infrastructures, and we get incremental innovations. And most importantly, to sustain these cycles, we need the last line back to the community. That is to contributing back to the community as a way that we're refilling the fuel tanks of these cycles. So now let me show you a real example in actions, beginning from the centers of this cycle, that is the engine of the cycles, infrastructure and platform. Doing the research in AI and HPC, it's hard to deny that what we need is high-performance computing chips, high-speed networking, fast local storage. However, these resources are very expensive, as you already may know, and not every research team utilizes these resources 24 hours a day. That is why we need to share it across multiple teams. And doing so is just not only maximize the hardware utilizations, but it's also foster the cross-disciplinary collaborations and innovation between different teams as well. Furthermore, many research teams, especially in AI, we share similar requirements for a tool to run our workload, and most of these tools are already available on the open source, so we can share from platform levels. On top of that, these infrastructures, the software stack, can fully built by the open source component, as I will show you next. This is the end-to-end AI workflow stack that built up in this cluster to cover entire cycles of the AI, data preparations, training, fine-tuning, and inference. So what keeps this stack especially powerful is the flexibility that you can plug in and plug out any capability on demand. For monitoring systems, we have open source exporter tools inside there, Prometheus, Grafana, and are many things integrated perfectly in our clusters. And this setup allows us to monitor our resource evaluations, and we can report directly from this one and see like anomalies, actions from our hypothesis. And last but not least, I would like to highlight what we have in these clusters is Kqueue. Kqueue is Kubernetes native system designed to manage queuing, quarter jobs in the shared cluster environments. Kqueue plays a very critical role in making a resource sharing both efficient and fair across the research team. The clusters, this cluster is used to queue the quota borrowing features from the Kqueue to manage and results in increasing the utilizations of the GPUs from 60% to 90% or more than 90%, which is very impressive results. And there's articles about that, like how does happen. And this is what happens a couple of years ago in our research department. A dedicated HPC clusters managed with LSFs was migrated and scaled out by adopting Kubernetes and open source tools from its ecosystem. And this unleashing the AI infrastructure and platform accessible to several research teams. In there are a bunch of the research projects using the shared cluster. We do developments, we do the prototyping, evaluations in many repositories from multiple research teams. And there are several academic publications, conference proceedings, and open access journal out there, and also their AI models like Granite family that we have on their Hacking page. Also, we have several articles out there for sharing our method and finding. Okay, I would like to take a moment back from this slide to the previous slide, which is the essential of this talk. Do you see what is missing here? So I just would like to focus here to highlight here that we shouldn't forget to refill our fuel tanks. That is open source project and community work. That is why we're here, and this is why I'm here as well. So after I joined the CNCF community for a while, I found that there are several ways, and also you can hear from our previous keynote talking about that. There are several ways that you can contribute back or refilling the fuel tanks, that what I mentioned here. One extreme way that I ever experienced is to donating the project and become the maintainer. That is the Kepler project that I was there. But for a simple start, as already our panelist has already mentioned, well, okay, we can join open source working groups. We can submitting our PR to the upstream, maybe start from upstream trainings. And then, of course, I also would like to encourage for submitting the talk and share your story to the community. Our meetup, it could be our KCDs, Cube Day, KubeCon, whenever or whatever, when you have a chance. Okay, for KubeCon Japan, we also have 3 sessions from IBM Research. That is from my colleagues and myself. One happened yesterday. You can still check the recordings. And the other 2 will happen today in the afternoon. One of that is my sessions with Lionel from Ericsson. We'll talk about our ideas about reimagining the Kubernetes network with the DRA. This includes my CAP as well, that is DRA consumable capacity. This is my first time to commit the PR for the CAP, and I would say working on this CAP, it has been very incredible learning experience to me. I have grown a lot from the valuable feedback and support from the maintainers and the reviewers. Thank you so much. And I would be also around at the maintainers meetup as well before a session, so please feel free to stop by and say hi, and maybe we can talk a little bit more. Finally, let me leave with this slide, and thank you for joining us.